again. So this is a part in which we are going to deal with the utmost important topic of probability, and that is sample space. Understanding this will lead you towards the terms of exhaustive, mutually exclusive and various other terms which we normally use in the questions of probability. If you can understand these things very clearly, you can crack any question on probability. So to get a deep insight into all these namings and concepts, let's go to the chapter of sample space and study.
So in the last part, you must have seen that I have used a word sample space. So this is a new word in this video lecture, so I think this must ring a bell inside your head. What is sample space that I am talking about? So let's understand what is sample space. Sample space, as the definition says, it's a set of all the possible outcomes that we can associate with some random experiment. And if you have associated a set of outcomes with that random experiment, the collection of all those total set of outcomes will come into the occurrence of sample space. So let's see. If I am tossing up a die, what can be the possible answers that I can have? 1 can occur, 2 can occur, 3 can occur, 4 can occur, 5 can occur, 6 can occur. If I am doing a collection of all these 6 values, then only I can say that it's a part of sample space, because that's what the definition says. It's a very understandable English definition in which it will just tell you that what are the different factors that you must consider while defining a sample space, and when the collection of all the possible outcomes can become a sample space and when it will not. That will be described by a bit mathematical definition into the next thing. So let's see. A sample space in terms of much more mathematical language, a list of exhaustive, which implies that don't leave anything out, which means if there is a basket in which we have 6 fruits, so if we are considering this basket to be an observation and we want to do certain probability calculations, it tells you that you have to consider all the 6 fruits, right? Suppose for an example, you are allowed to do a certain work on the meteorological department in which you'll have to define and explain that what will happen after 2 days. So what you will do, first of all, you take all the possible datas that you might be having in your server or anywhere. You will have to collect all of them, and in order to get a specific probability, and that too an exact one, you need to have all the possible set of data which will be exhaustive in its sense, and similarly mutually exclusive outcomes, which is impossible for 2 different events to occur in the same experiment, which is exactly equal to the fact that if I am considering that rain will happen or rain will occur tomorrow, so if I am considering this, I cannot consider that rain will not happen tomorrow, right? So negative of this will automatically tell me what is the exact proportion in which rain will not happen tomorrow, but the number of possible events or outcomes which are there into this cannot occur into the other one. So that is what the specific meaning of mutually exclusive is. And the sample space is denoted by a capital S. See, what are the different outcomes that we denote by O? And if you're starting from the first will be called as O1, after that we'll call it as O2, after that O3, and we'll go till on the nth place, right? See, all these notation that we have obtained, we use a basic mathematical definition from a place which is known as set theory, because set theory only deals with all these kind of outcomes and notation things. So the sample space in probability, and if we are considering outcomes in terms of O1, O2 and O3, they will be cumulatively represented by this. You'll have to write S in caps along with there a curly brackets. It's the same method in which we have written the sets. So this is also a representation of different outcome in terms of sets. So O1 is the first outcome, O2 is the second, and OK is the kth outcome. So let's go a bit deeper into the probability thing from the sample space. If we have given a sample space that is O1, O2 and O3 till OK, so what will happen to the probabilities that are assigned to this? So let's see what will happen. As we all know that probability of any outcome is from 0 to 1. And how can we say that? It's very easy to understand, because if a thing is going to happen, either it may happen 0% or it may happen 100%. So the probability is, if it's happening 0%, it's equivalent to 0, and if it is happening 100%, it's equivalent to 1. And this is how we notify the probability. OI is the ith outcome, and the P that we have written outside will symbolize that we are interested into the probability of this. So for every possible outcome, the probability is going to range from 0 to 1. That is what is the meaning of probability of any outcome is between 0 to 1. Next, if we have considered the sample space accurately, the sum of probabilities of all the outcomes will give us a definite value, and that will be equal to 1. So let's understand how this is happening. So suppose if we consider an experiment in which there are only two possible outcomes. Suppose I am flipping up a coin. Either I can end up with a head or I can end up with a tail, right? If I am ending up with a head, suppose, and the probability is 2 by 5, right? Suppose it's a biased coin and the probability of getting up a head is 2 by 5. So it is pretty sure that the getting of probability of a tail is nothing but 3 by 5. And see, I have considered the complete sample space. That is why the answer that I'll get, if I'll add these 2 by 5 plus 3 by 5, and that will be 1. So this is what is symbolized over here. So in crude mathematics, we can write it as summation of POI, where OI is the observation ith, where I runs from 1 till k, sum is equal to 1, and POI represents the probability of an outcome I, and PO1 represents the probability of first outcome, and similarly PO2 represents the probability of second outcome. So this is how the sample space is so important in understanding the probabilities, which we are going to deal into the next videos.
So from the very start, I hope we have done the random experiment and the sample space, and also have learned the various concepts of exhaustive events and the various definitions which deal with all of this. As I've told you in the very start, the understanding of all this is very important, and I hope that you would have clearly understood and do keep a watchful eye on all the concepts that have been shown in this part. In the next part, we are going to deal with the definition of probability and the various events that are associated with it. So stay tuned for the next part.